So we will discuss the concept of specific heat of water and the calorie here. The subject of calorimetry was developed during the middle of some 18th century, and at that time all the measurements were limited to the temperature range of 0 degrees Celsius to 100 degrees Celsius, which represents the temperature range of the freezing and boiling points of water. And the unit of heat used at that time was calorie, it was not joule. And 1 calorie was defined as the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. So that was the definition accepted for calorie. So 1 calorie is equal to the amount of heat required to raise the temperature of 1 gram of water. So it is defined in terms of water, the common liquid, by 1 degree Celsius. That was the definition of 1 calorie. And see, when accurate instruments were developed at the later part of the century, it was found that the heat required to raise the temperature of 1 gram of water from 0 to 1 degree Celsius is different from that required to raise the temperature, say, from 30 to 31 degrees Celsius. So if you have got 1 gram of water and you just have see that you are supplying some amount of heat equal to d bar q1, let me call, to raise the temperature from, say, 0 to 1 degree Celsius. You took 1 gram of water and you are heating it so that the temperature is rising from 0 degree Celsius to 1 degree Celsius. So let d bar q1 be the amount of heat required. Now let us say that I am heating 1 gram of water from say another range, 30 to some 31 degree Celsius, 30 to 31 degrees Celsius. So for that you need to supply heat energy, and it was found by using accurate measuring devices. The heat required in the second case is not equal to the heat that was required for the first case. So means this one, let me call it as d bar q2, and this d bar q2 was not found to be equal to d bar q1. So that is the thing that they observed. D bar q1 is not equal to d bar q2, means the values are not equal. Hence they had to redefine their definition of calorie to make it more specific by telling the temperature range. So what they did, that they defined calorie to be the heat required to raise the temperature of 1 gram of water from 14.5, that is the thing that they have taken, degree Celsius to 15.5 degrees Celsius. Again the difference is 1 degree Celsius, but it is neither 0 or not 31. So they took an intermediate range and they defined to, just like taking a mean temperature, they took the calorie to be the amount of heat required to raise the temperature of 1 gram of water from, it was made specific. They didn't tell that by 1 degree Celsius. They told it should be from 14.5 degrees Celsius to 15.5 degree Celsius. And this definition of calorie was named as the 15 degree calorie. That is a historical thing. There is nothing that much important for us for today. 15 degree calorie. It is only a historical fact, only to tell you that there were some history behind the present or adopted definition of heat or calorie. Now see later just as you know that people were interested in knowing the amount of work that has to be dissipated. So later another quantity was defined, what is known as the mechanical equivalent of heat. See, that is another thing that you already have read as a part of your first reading assignment, where you have learned about the Joule's heating experiment and all, where it was defined as the mechanical equivalent of heat. And this is the only concept. These are all related concepts from different angles or perspectives. Here they tried to focus on the amount of work done, mechanical work done, instead of focusing on the amount of heat that has to be transferred to raise the temperature. They focused on the equivalent work done that has to be transferred to raise the temperature of 1 gram of water. See, it's just telling that you can change the internal energy of a system either by transferring heat or by doing work. This is the basic concept of first law of thermodynamics. So the basic definition of calorie was based on how to raise, or amount of heat required to raise the temperature by 1 degree Celsius, and the mechanical equivalent of heat is related to changing the temperature by doing work on the system. So that is where we come to the mechanical equivalent of heat. See, it was defined as the amount of work. So you have to just see the similarity. Amount of work needed or required to raise the temperature of, you can say, raise the temperature of, just compare this definition with the definition of 1 calorie that I have given. Okay, raise the temperature of unit mass. Unit mass means you can take 1 gram or 1 kilogram. Accordingly, there will be a change in the value, numerical value. Raise the temperature of 1 gram of water by 1 degree Celsius itself, but we will be defining it exactly, precisely from, this is the way in which it was defined, from they adopted a temperature range 14.5 degrees Celsius to 15.5 degree. That's an arbitrary range, but it was adopted historically, 15.5 degree Celsius. And they found that this value is equal to, this value, or the value of mechanical, was found to be equal to 4.186 joule per gram. Means 4.186 joules of work had to be done to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degree Celsius. And later, you know that this mechanical equivalent of heat, it was defined in terms of work, and here it is calorie was defined in terms of heat, and both the conditions were the same. We have to raise the temperature of 1 gram of water by 1 degree Celsius. So we can say that logically 1 calorie should be numerically equal to the mechanical equivalent of heat. That is a very logical, direct logical conclusion that can arrive at. So later what they did, they accepted the fact that the mechanical equivalent of heat is really equal to the numerical value of calorie, and further it was understood that this mechanical equivalent of heat is equal to the specific heat of water if you take joule as the unit of heat. So you can just say that finally this is the conclusion that we arrive at. The specific heat of water, I can say CW, small c I am using, remember, that is equal to the mechanical equivalent of heat, which is nothing but 4.186 joule per, what is that, gram. And of course, when you say that you are using specific heat, okay, you can say per Kelvin also. So the numerical value you can just put up in proper units. So that is the thing. So now we have actually equated the numerical value of three of the quantities. One is the definition of calorie and its relation to joule. 1 calorie is equal to 4.186 joules. That is one thing that would say. So these are the things, just to see that we are actually doing the numerical equivalence. So 1 calorie is equal to 4.186 joules, which is what you roughly write as 4.2 joule. Okay, then we came to what is known as mechanical equivalent of heat. I am not using any symbol for that, and that was found to be having 4.186 joule per gram. Okay, and finally we come to the specific heat capacity of water, which is 4.186 joule per gram per Kelvin. So you can see the difference in the units that is associated with each of these three quantities. So you can see this particular fact, including joule, if you want, you can do. So this particular thing is the same in all the three definitions. That is only a historically developed fact. Okay. Now, see, to give you an idea about the variation of specific heat of water with temperature. Okay, the specific heat is depending on temperature of the system as well as the pressure of the system. You can see the graph here shows the variation of the specific heat of water with respect to temperature. Better here it is given as joule per gram. You can read it as joule per gram per degree Celsius or per Kelvin. Now you can see it is not a constant. Specific heat of water is not a constant. So it varies with the temperature. So it was high and then it reduces, then see it becomes a minimum and then it goes on increasing. And I hope you remember I told you that water is having an anomalous behavior in terms of its density, and you will see that the density of water is maximum at 4 degrees Celsius. So accordingly there will be a similar change in the heat capacity also. So just remember one fact that we already stated, that the heat capacity of a substance is a function of the temperature, the pressure, the volume, etc. So when you are doing usually problems and all, you usually take the average value of the heat capacity over the range of all these variables involved. Okay, so but always remember this heat capacity C, whether it is heat capacity or the specific capacity, it has got a dependence on the experimental conditions that we are adopting. Okay, thank you.